Next, we move on to preparing data for modeling. So we have numerical columns is equal to customer features. I'll select D types include np.number columns all the way down to feature customer features is bracket numerical columns for customer features and numerical columns fill NA0. Basically, this block of code basically replaces any missing values within like numerical columns with with 0 to prevent like issues during like modeling or like feature engineering. Then we move on to basically creating additional time-based features for like max monthly spend, average monthly spend, and spend STD. And then we move on to like basically preparing for modeling with feature columns all the way equal to Regency, spend STD all the way down to Y is equal to customer features with future SLV. Basically feature columns basically defines like the features to be used for like modeling, which is Regency all the way to spend STD, and then X is equal to like the feature matrix and Y is equal to the target variable of like feature SLV. Then we move on to valid ID X equal to Y is greater than 0 and X dot sum brackets X is equal to 1 is greater than 0 all the way till Y is equal to Y brackets valid ID X. Basically with this block of code basically filters out the customers with no future SLVs, such as which is like Y is greater than 0, and no valid features such as like X dot sum X is equal to 1, which is greater than 0. Then we move on to X is equal to X dot replace NP infinity negative NP infinity NP nan dot drop NA. Basically this replaces like the infinite values with nan and like removes like the rows with any missing values. And then we have Y is equal to Y dot Y lock brackets end index. Basically this assigns the target variable of Y with like the clean feature matrix of X. Then we move on to selector is equal to variance threshold is equal to 0 all the way till X is equal to pd.data frame selector.fit transform X columns is equal to X columns brackets selector.get support brackets. Basically what this line of code does, it basically removes any features with like 0 variance, and basically this is to like eliminate redundancy features that don't contribute to the model at all. Next, we move on to handling outliers by capping like extreme values. So for call and X columns all the way down to like X call is equal to X brackets call dot clip upper equal to cap value. Basically this caps like the extreme values are like the 99th percentile to handle outliers, and this is basically done to reduce like the impact of like extreme values on the model. Then we move on to basically splitting the data with X train X test, Y train Y test is equal to train test split with the parameters over here. Basically this line of code basically splits the data set into like training and testing sets, as 80% goes into training and 20% goes into testing. Then we move on to Y train log is equal to np.log Y train, and then Y test log is equal to np.log 1p Y test. Basically this applies like the log transformations for like the training and testing sets. Then we move on to skewness is equal to extron.screw, print f defect length as skewed features by highly skewed features. Basically what this block of code does, it basically identifies features with with high skewness, which is like the absolute skewness is basically greater than 1. Then we move on to x train t is equal to x train.copy, and x test t is equal to x test.copy. Basically what this block of code does, it basically creates like a copy data frame to preserve like the original data set. Then we move on to plt.objects is equal to empty brackets all the way till print warning transformation columns is equal to E. Basically what this block of code does, it applies like a simple rule. If the column is like strictly positive, use np.log, and if it's negative, use the power transformation or like the Johan-Johnson method, which like supports like zeros and like negative values. Then we move on to scalar.choice is equal to robust all the way down to scalar is equal to standard scalar. Basically what this block of code does, it basically chooses the scalar choice of robust as the default because it's less sensitive to outliers. Else we use standard scalar. Then we have x train scaled is equal to scalar.fit transform x train t, x test scaled is equal to scalar.transform x test t. Basically this block of code basically fits the scalar transformation on like the training and testing sets. Then afterwards we print out the shape of x train.shape, x train scale.shape, and then we print out like the transform feature statistics by using pd.data frame, x train scaled columns, x train t columns, I lock to 0 till 8.describe t.head. So here we have detected 16 highly skewed features, regency all the way till spend 2011, 08. Then we have like the shape before and after of 1,561 rows with 16 columns, with 561 rows with 16 columns. Then we have the statistics for each, for like the mean all the way to like max for like the categories of recency, frequency, total quality, all the way down to max month spend. So yeah. Next we move on to model training and evaluation. So model is equal to rich brackets alpha is equal to 1, all the way to model.fit x train scale and y train log. Basically what this block of code does, it initializes the ridge regression model with like an alpha value of like 1, and basically fits like the model to the scale training data of x train scaled and the log transform target of like y train log. Then we move on to y predict log is equal to model.predict x test scale. Basically this block of code predicts like the log transform target variable. And then we have a y predict.np.xm, a y predict.log. Basically this transforms the predictions back to like the original scale. Then we move on to evaluation. So MAE is equal to mean absolute error, a y test, y predict, all the way down to print r squared score with r2 with 0.2f. Basically what this block of code basically evaluates the metrics of like the mean absolute error, mean squared error, root mean squared error, and like the r score, and basically and then it prints them over here. Then we move on to feature importance is equal to pd.data frame all the way down to like sort values coefficient, ascending is false. Basically what this block of code does, it basically creates like a pandas data frame to store like the features names and like the corresponding coefficient from like the ridge regression model, and basically it sorts the features by their coefficient in like a descending order to like identify like the most influential like features. Next we basically print out the top 10 features by using feature importance.head. So here's our output, the model performance for predicting future SLV. So mean absolute error is equal to 746.2 all the way down to like r squared score, which has like a score of 0.5. Here we have like the top 10 features for this model. So the first feature is like frequency of like 0.72583 all the way down to like span 2011 over 04 with like a coefficient of 0.046276. Next we move on to evaluating like the random forest regression model. So RF model is equal to random forest regression with this parameters over here, and RF model.fit x train scale and y train scale. Basically what this block of code does, it basically trains like the random forest regression, a random forest model, and basically fits the data. Basically fits the model to the like the scale training data and like the log transform target variable of like y train log. Then we move on to RF y predict log is equal to RF model.predict x test scale. Basically what this block of code does, it basically predicts like the log transform target variable, and then RF y predict is equal to np.exam RF y's predict log. Basically what this block of code basically like transforms the predictions back to like the original scale. Next we evaluate the metrics and like print out the output. So here we have RF ME is equal to mean absolute error, y test, and RF y predict all the way down to r squared score is equal to RF r squared 0.2f. Basically this block of code basically evaluates the metrics of like mean absolute error, mean squared error, root mean squared error, and like r squared, and basically prints out the output. Then we move on to our feature importance is equal to pd.data frame all the way down to like sort values importance, ascending is false. Basically this block of code basically creates like a pandas data frame to store like the feature's name and its importance, and basically it sorts the features by the importance in like a descending order. So here we have like the top, and then we print out the top 10 random forest features importance with our feature importance.head.10. Basically here's like the metrics for like the mean absolute error of MME with like 734.59 all the way down to like r squared score of like 0.51. Here we have like the top 10 random forest feature importance, from first one being like the average monthly spend of like 0.09959 all the way down to spend 2011-03, which has like a score of like 0.02145. Then we move on to model comparison. So print metrics less than 10, ridge is less than 12, random forest is less than 15, better model all the way to r squared less than 10, r squared less than 12.3f, RF is RF r squared is less than 15.5 for f, And ridge is if ridge is r squared is greater than rf squared, else is random forest. Basically what this block of code does, it basically like compares like the performance of like the ridge regression and like the random forest models for the metrics of like mean absolute error, root mean squared error, and r squared. Then we basically set up like a figure with like a width of like 12 inches and 15 height for like visualization of like the predict versus actual scatter plot and the residual plot. So plt dot subplot 1 to 1 plt dot scatter y test y predict alpha is 0.5 labels ridge, all the way down to plt dot grid true is alpha is equal to 0.3. Basically what this block of code does, it basically creates like a scatter plot comparing the actual like customer lifetime value of like y test to the predicted values for like the ridge of y predict and like the random forest of rf dot y predict. Next we move on to residual plots with plt dot subplot 1 to 2 plt dot scatter y predict y test minus y predict alpha 0.5 label ridge residuals, although to plt.grid comma true is equal to alpha dot 3. Basically what this block of code does, it basically creates like a residual plot for each of the model and showing like the difference between like, and the actual and the predicted values for the ridge regression model and the random forest model. Then we plot all these visualizations into one with plt.title layout and plt.show. So here's our model comparison summary. So here are the metrics. Here are all the metrics. Here's the model of ridge, a random forest, and this gives us a better model. So for the metrics of mean and absolute error, we have a ridge with like 746 compared to the random forest model. So the random forest model is better. Then we have the root mean squared error with a ridge having 2011 as compared to the random forest of 1900. So the random forest model is better. Then we have r squared with the ridge has like with points 447 and random forest is at points 506. So the random forest model is better. So basically the random forest model is basically outperforming ridge in the metrics of like the mean absolute error, root mean squared error, and like r squared overall. Then here we have like the visualizations for model prediction comparison and residual comparison. So for the model prediction comparison, the orange dots represents like the random forest models. The orange dots are like very closer to like the actual perfect prediction line as compared to like the ridge points over here, showing like that the random forest is generally closer to reality. And then we have the residual comparison model. So the higher the customer lifetime value is, the greater the residual is for at least for the ridge residual as compared to like the random forest residual, which is closer to like the actual line. So this was our overall project. Thank you for listening and watching.